All right, ready to dive deep. Today we're getting into some seriously elemental stuff, hydrogen. But I know you guys, you're not here for just the basics.
Definitely not. We're going way deeper than that.
Exactly. We're talking about how this tiny little element, hydrogen, is basically woven into, well, everything.
It really is. From the water we drink to the stars in the sky, hydrogen is there.
So where do we even start with something that's like everywhere and in everything?
How about something I'm sure you're familiar with water?
Okay, I can work with that.
Ever wonder why ice floats? Or why it seems like it takes forever to boil water for tea?
Honestly, I've just accepted those as weird water facts. Like, that's just how water is.
Well, there's a reason for that. It's this really cool force called hydrogen bonding. Think of it like an invisible web that holds all those water molecules together.
So these hydrogen bonds are like tiny little magnets.
That's actually a great way to think about it. So in a water molecule, you have oxygen, and it tends to hog all the electrons, which leaves the poor hydrogen atoms kind of left with a slightly positive charge. And that positive end, well, it's attracted to the electron-rich oxygen atom of another water molecule.
Okay, so there's this whole electron sharing drama happening, and that's what makes water so special.
It's a big part of it. Even early scientists, I'm talking like Humphrey Davy, were totally puzzled by how strange water behaved. And, it actually took some really brilliant minds like Linus Pauling to really figure out these hydrogen bonds and how they work. But get this, these bonds, they aren't just in water.
Seriously, there's more.
Oh, yeah. They're super important for the things that make life itself possible. DNA, proteins, all that good stuff.
Wait, hold on. Those tiny little bonds are holding our DNA together.
You got it. They're why DNA looks like that cool twisted ladder, the double helix. And for proteins, they help create those really complex shapes that, let proteins do all their important jobs.
That's honestly mind-blowing. I never realized something so small could be so important.
It's a good reminder that big things come in small packages, right? But we've talked about hydrogen bonding. Now let's actually talk about the hydrogen molecule itself. H2.
So now we're talking about hydrogen in its purest form.
Exactly. This is where we get down to the nitty-gritty of atoms and how they interact with each other. We have to thank some early chemists for this, people like Avogadro and Gay-Lussac, for discovering that hydrogen prefers to be in a pair, forming that H2 we all know. It's a really strong bond called a covalent bond.
Covalent bond. Okay, so is that like two hydrogen atoms, like holding hands?
Essentially, yeah. They're sharing their electrons, which makes them more stable, lower energy, kind of like helium.
So it's all about finding that perfect balance, that stability.
Exactly. And once you understand these tiny interactions, it opens up a whole new understanding of chemistry. It's fascinating.
Okay, so we've talked about hydrogen bonds. We've talked about the hydrogen molecule itself. I feel like we're building a pretty good understanding of this, like, tiny but mighty element. What else is there? What's next in our hydrogen adventure?
Well, now we're going to talk about hydrogen's kind of explosive side.
Oh, I think I know where we're going with this. Is this about the Hindenburg disaster?
You got it. That disaster is a pretty good example of how reactive hydrogen can be, especially when it gets together with oxygen.
Yeah, because hydrogen and oxygen, they don't just like politely coexist, do they?
Not at all. They get together and boom, huge release of energy, and we call that combustion. The byproduct, of course, is water, and it's this powerful reaction that makes hydrogen super useful, but also potentially dangerous if you're not careful.
It's like the chemical version of Jekyll and Hyde.
Right.
And capable of great things, but also capable of some serious destruction if it's not treated right.
That's a great way to put it. But before we get into some of the ways we use this reaction today, it's worth taking a little trip back in time because the story of how we even figured out combustion, it's actually pretty fascinating.
I'm always up for a good history lesson, especially if it involves explosions.
Oh, well, this one involves a brilliant chemist named Antoine Lavoisier. He's the one who basically debunked this whole old theory about fire called the phlogiston theory.
What theory? Okay, now I have to know. What is the phlogiston theory?
So imagine this. For centuries, scientists thought that when something burned, it was releasing this mysterious substance called phlogiston, basically like a fire element that was escaping into the air.
Okay, I kind of get it. So, like, fire's in there, and when it burns, the fire escapes, leaving behind whatever's left.
Right, except Lavoisier wasn't buying it. He was like, I don't think so. So he did all these incredibly precise experiments, and one of his most famous ones, he passed steam over red-hot iron.
Sounds intense. What happened? Did he, like, accidentally create a new kind of steam engine or something?
Not quite, but he did make a huge discovery. He found that this reaction produced hydrogen gas and iron oxide. And this proved that water could be split into hydrogen and oxygen. And this was revolutionary because it meant that combustion wasn't about some mysterious substance escaping. It was about things combining with oxygen.
Leave it to a scientist to take all the mystery out of fire. So
Yeah.
no magical fire element, just good old-fashioned chemical reactions happening. Speaking of which, we talked about the Hindenburg. But that same reaction, that's what sends rockets up into space, right?
Exactly. Liquid hydrogen and liquid oxygen, that's rocket fuel. It gives rockets that massive amount of thrust they need to break free from Earth's gravity.
Wow. It's kind of amazing to think that the same thing that caused so much destruction could also help us explore the universe.
It really shows you the power of hydrogen. But let's switch gears from these big dramatic examples to something a little more, well, down to earth. Did you know that hydrogen is actually how we measure how acidic something is?
Really. So that lemon I put in my tea this morning, the reason it's so sour is because of hydrogen.
Exactly. That sourness, that tartness we taste with acidic things, that's because of hydrogen ions, or H. And the pH scale, that measures acidity, it's directly related to how many of those hydrogen ions are in a solution. More hydrogen ions, more acidic it is.
So something with a low pH, it's basically swimming in hydrogen ions.
You got it. And the whole study of acids and bases, it's got a fascinating history. You have Arrhenius, who initially defined them based on how they acted in water. Then came Brensted and Lowry, and they focused more on this transfer of hydrogen ions, those protons we've been talking about. They realized it wasn't just about the hydrogen itself, but about how easily it could, hop around as a positive ion.
So it's like a game of chemical hot potato, but with hydrogen ions.
Exactly. And this proton hopping, it's crucial for so many chemical reactions, from the food we eat to the really complex processes happening inside our cells all the time.
Okay, wait a minute. We've gone from explosions to a rocket fuel to the food we eat. Hydrogen is way more versatile than I ever imagined.
It really is. And we haven't even gotten to all of it. Remember earlier we were talking about hydrogen as a reducing agent?
Refresh my memory. What exactly does that mean again?
It's all about giving up electrons. Hydrogen, in certain reactions, it acts like this generous donor. It'll just give its electron to other molecules. And that giving of an electron, that's called reduction. And it's super important for a ton of industrial and biological processes.
Okay, I'm seeing a theme here. Hydrogen, the giver of electrons, the fuel of stars, the reason why things are sour. So tell me more about this reducing agent thing. What do we actually use it for in the real world?
Okay, so hydrogen is this, like chemical Robin Hood, taking electrons from the rich and giving them to the poor. I like it. But in reality, what does that actually look like? How do we use that? Well, it means that hydrogen is how we get pure metals from their ores, and we've been doing it for ages. Remember when we were talking about Lavoisier and that experiment he did with passing hydrogen over hot metal oxides? That's hydrogen as a reducing agent. And today, we still use it in a bunch of industrial processes. Everything from making super pure metals for electronics to making something I bet you have in your fridge, margarine.
Wait, margarine.
Yeah.
Hold on. How are we going from extracting metal from the earth to my toast?
It's all thanks to this process called hydrogenation. So fats, the things we need in our diet, they can be in a few different forms. You've heard of unsaturated and saturated fats, right?
Yeah, the good fats, the bad fats. I can never keep them straight.
Basically, unsaturated fats, they're usually liquid at room temperature, like olive oil, but you can actually change them into saturated fats, which are solid at room temperature, through hydrogenation. You're basically just adding hydrogen atoms to the fat molecules, which changes their structure, and that changes how they behave.
So you're saying they pump hydrogen into oil and it turns solid.
It's a little more complicated than that, but yeah, that's basically the gist. And it's just another amazing example of how we can take this reactive little element and use it for all kinds of things.
Okay, we've covered explosions, we've talked about acidity, now margarine. Hydrogen is way more involved in our everyday lives than I ever realized.
And we're not even done. So remember how we were saying that hydrogen bonds are super important for DNA? They're also essential for another really important type of molecule, proteins.
Proteins, right? Those are like the little machines that make our bodies work.
Right. Perfect way to think about it. Proteins do so much. They carry molecules around, they make reactions happen. But for them to do all that, they need to be these very specific shapes. And guess what helps make those shapes?
Hydrogen bonds.
Exactly. Hydrogen bonds stabilize all those elegant little structures that proteins are made of, things like alpha helices and beta sheets. It's those tiny interactions that make sure the proteins fold up correctly, which lets them do all their jobs. It's amazing.
That's incredible. So those little bonds are basically shaping the very tools that make life possible.
It all comes back to those bonds. It's like this beautiful dance between chemistry and physics, all orchestrated by this one tiny element. And speaking of hydrogen's many talents, we can't forget about its potential as a clean energy source.
Right. Hydrogen fuel cells. That's something everyone seems to be talking about these days. So
Yeah.
how do those actually work?
Remember that powerful reaction we were talking about earlier between hydrogen and oxygen, the one that makes rockets go?
Hard to forget that one.
Well, fuel cells use that same reaction, but they do it in this really controlled way. And instead of a huge explosion of energy, it creates electricity. So you get clean energy.
So instead of making things explode, we can use it to power our homes. What's the downside?
The tricky part is figuring out how to produce and store hydrogen in a way that's efficient and doesn't cost a ton of money. But the potential is huge. Imagine a world where we could power everything using the same element that makes up most of the universe.
Pretty amazing, right? Wow. We really have covered a lot today, haven't we? We've gone from the mysteries of water to the vastness of space, the food we eat, and even what makes life possible in the first place. And it all comes back to this one little element.
It just shows you sometimes the smallest things can have the biggest impact.
It really does. Well, we've covered a ton of ground in this deep dive: hydrogen bonds, rocket fuel, even the future of clean energy. So for our listeners, what's the one thing you really want them to take away from all of this?
I think the biggest takeaway is to never underestimate the power of curiosity. Hydrogen, this tiny little element with just one proton and one electron, it's shaped our entire universe, and we're still discovering new things about it all the time. Who knows what else we'll learn as we keep exploring.
I love that. Always keep asking questions. Well, on that note, thanks to everyone for joining us for another deep dive. And until next time, keep exploring the wonders of science.